Welcome back to another Daishinfinity video. In this video, we're going to prove the derivative of cosecant hyperbolic of x. It states that the derivative of cosecant hyperbolic of x is equal to the negative of the cosecant hyperbolic of x times the cotangent of hyperbolic of x. So in this video, we're going to prove it using our limit definition of our derivative. Now, the definition of a derivative, so the d dx of a function given f of x, is just equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Since f of x is cosecant hyperbolic of x, we know that cosecant hyperbolic of x is equal to 1 over the sinh of x, the sine hyperbolic of x. Now, what is sine hyperbolic of x? Sine hyperbolic of x is equal to e to the x minus e to the negative x over 2. So if we take everything to the negative 1 power, we know it's the same thing as cosecant hyperbolic of x, which is equal to 2 over e to the x minus e to the negative x. So we can use this in our limit definition. Leaving us with the limit as h approaches 0 of 2 over e to the x plus h minus e to the negative x minus h minus over e to the x minus e to the negative x all over h. So now we're just going to cross multiply our fractions in order to get the limit as h approaches 0 of 2e to the x minus 2e to the negative x minus parentheses 2e to the x plus h minus 2e to the negative x minus h all over the product of those three, the denominators of those two fractions and the h times e to the x plus h minus e to the negative x minus h times e to the x minus e to the negative x. Now we're just going to distribute the negative sign in front of our parentheses. So we're just going to get the limit as h approaches 0 of 2e to the x minus 2e to the negative x minus 2e to the x plus h plus 2e to the negative x minus h. And the whole thing over h times e to the x plus h minus e to the negative x minus h times e to the x minus e to the negative x. Now we can take the e to the x minus e to the negative x out and the 2 so that we can get our cosecant hyperbolic of x times the limit as h approaches 0 of e to the x. Now I'm going to take the e to the x outside, so we get e to the x times 1 minus e to the h. Then we have e to the negative x times e to the negative h minus 1. And the whole thing divided by h times e to the x plus h minus e to the negative x minus h. Now if you look at this, we can let this part of the denominator be a single limit, since the limit definition we have that the limit of f times g is the limit of f times the limit of g. So since we have this in common, we can split the limit into two, considering two limits. We have cosecant hyperbolic of x times the limit as h approaches 0 of e to the x 1 minus e to the h over h plus another limit where e to the h approaches 0 of e to the negative x times e to the negative h minus 1 over h. Now this whole thing times the limit of 1 over e to the x plus h minus e to the negative x minus h. Now here h approaches 0, here h approaches 0, so this will approach 1 over e to the x minus e to the negative x, which is just the same thing, almost the same thing as cosecant hyperbolic of x. But we have a 2 that is failing, so we have to multiply 2 and here 2, so that we have 1/2 cosecant hyperbolic squared of x times e to the x, so we can put the e to the x's out of the limit, times the limit as h approaches 0 of 1 minus e to the h over h, plus the limit, the e to the x, a to the negative x times the limit as h approaches 0 of e to the negative h minus 1 over h. Now we can use L'Hopital's because we have a 0 over 0 situation, so we are just going to take the derivative with respect to h on both sides. And then since we have e to the h and e to the negative h, we will get 1/2 cosecant hyperbolic squared of x times e to the x of the limit as h approaches 0 of negative e to the h over 1 plus e to the negative x of the limit as h approaches 0 of negative e to the negative h over 1. So this will approach -1, this will approach -1, and then we can take the -1 outside, so it will be 1/2 cosecant hyperbolic squared of x times e to the x plus e to the negative x. And since e to the x plus e to the negative x times 1/2 is equal to the cosine hyperbolic of x, so we can write it's negative cosecant hyperbolic squared of x cosine hyperbolic of x. And since cosecant, one of the cosecant is 1 over sine hyperbolic of x, we can state that this thing is equal to cotangent hyperbolic of x, which means that we have proven the formula negative cosecant hyperbolic of x times cotangent hyperbolic of x. I hope you really enjoyed this video. Please like and subscribe and follow for more, and we'll see us definitely in the next Daishinfinity video. See ya.